Hello everyone and welcome back to another fun lesson about WebGL and today about WebVR. Today we're going to experiment with Vive Controllers. So we're going to access these little bastards and have fun with them today. In today's lesson we're going to load up some files that has cross-domain errors if you're loading them like locally. So we need to kind of modify the shortcut for our experimental Chrome version, that we use for WebVR. Just make a shortcut and just add these to the target. It's just disable web security and user data dir. That's it. That's all we need, and that would set up our browser so we can do WebVR and load up files through Ajax. So we're going to start off first is fixing a bug I found. A bug I found was inside our transform.js file. If we go to update matrix, the order originally was X, Z, Y. The order needs to be Y, X, Z. And especially since I put this little comment saying very important, I screwed up the order importance. So yeah, today I found, because I spent so much time with the camera and not with the actual model transform, that I didn't realize that the model is also broken. But I did fix the camera a couple of lessons ago. So that's one bug fix. And the other thing that I'm kind of happy about, in the previous lesson where we're head tracking, I was doing a bunch of inverts. This is how it was originally. Oh, not this one. That. It was like this. So we created our translation or matrix, whatever. We inverted it. Then we did a multiply of that matrix that we created with the stage view matrix invert. Remember, we were inverting the stage view matrix to do the rendering of the left and right eye. So, and then we invert it again. And what I really wanted to do was this line, where I wanted to use the sitting to translation, the translation that's not inverted, the original, with our mat, and it didn't work. And I really wanted it to work that way because I didn't like all these inverts, kind of getting in the way and slowing. I don't want this happening in every frame. And when I was looking on how to track the Vive controllers, they actually had a slightly different way of doing it. And the only difference, it was the way I wanted to do it. The only big difference between how I want it to work and how it does work, again, it's an order issue. If I would just put that multiplied by the transform matrix that we just created, it works perfectly now. You can do head tracking, and we can track the Vive controllers with the exact same 2 lines of code without all those inversions. Awesome. So that's a great improvement, I think. That's great. I love it. I'm very happy about that. So now we got the bug fix, 2 bug fixes out of the way. Well, this is not a bug fix. This is just an optimization improvement. Now we're going to go to the meat and potatoes of today's lessons. Today we're going to track the Vive controllers. So we're going to create a new class in our vr.js file. And we're just going to call it a VR pad for now, because I don't know what else to call it. So in our constructor, we're going to set up a couple things. We're going to pass in our VR instance reference so we can access some things, I think. I don't think we actually need to use this, to be honest. But it's here for just in case we need it. Oh yeah, we do need it. That's right. Never mind. It's late again. I'm always recording when it's late and tired. So we're gonna keep track of the left and right hand pads since the Vive have 2 controls. And today we're only gonna deal with the right pad, because once you get the right pad right, you get the left pad's the same thing. So we're gonna create an object that's going to keep a state of the controller. So the reference is going to be the actual object reference that we're going to pull. It's kind of like a frame data. every time a new frame happens, we have to do frame data, like how we did with VR headset. So we got to get the data of the controller, and then that's where I save the reference to it right here, so I can reuse it when I need it. We're going to keep track if the trackpad is being touched. We're going to keep track of the trackpad is being pressed into, like the button. We're going to track the value of the trigger, because if the trigger is not being pressed, it's 0, and if it's pressed all the way, it's 1, and if it you have any value between 0 and 1. Trigger also has a pressed and touched feature, or data, and I don't like how to me it's still finicky. I feel like I have more control if I just do it by trigger value. Then we have grip. Are you gripping? Yes or no? And then it's kind of like the menu button that's on the Vive controller, that we can tell if it's being pressed in or not. So we're going to keep track of that for every update. I made some functions that I think I'm not using yet, but might be useful in the future. Is the left, is the right available? Very easy. Then we have the update. So every frame we're going to call an update. And so why is pad? I think this is meant to be reference. I made a bug. I kept rewriting these things. Save. Okay. So yeah. So we're going to reset the reference to every frame. And in every frame, we're going to call navigator get gamepads, which gives us an array. I think it gives us like an array of 4, which is kind of odd. So I guess it only tracks up to 4 controllers at once. Or my computer, for some reason, has 4 controllers. That's known. I don't know why it gives me 4. But it's like an array of 4 elements for me. It might be different for you. Just output array with a console.log and just to see how it looks like on your computer. And for me, it gives me 4. So I have to loop and see, first of all, is it not null? Is it like an object? And check if it has a pose. If it has a pose, it's the Vive controller. That's where a lot of information is going to come from the pose object. Just like how the headset has a pose object. It gives us the orientation and the position and all, the orientation and position of the headset. So the Vive controller, it works kind of similar. It has the pose, and it pretty much almost the same thing as head tracking. Pretty much. And inside of it has an index. So if the controller has an index of 0, it's the first Vive controller that I guess was turned on and it was read in by the Steam VR system. And if it has an index of 1, then it's the second controller. So I'm just going to automatically say, if you're the first controller loaded up, you're the right pad. If you're the second controller loaded up, you're the left pad. That's it. And while I'm here, once I'm done doing the update, I'm going to do test buttons, which is going to test the button 0. Ideally, it should probably be called twice. So this way you can update. So I'll update to the right and left pad state. So, but for now, I'm only working with the right pad. So I'm just gonna test buttons. It's not a great function name. I'm sorry. Give it a better name. I guess update. Maybe it should be called like update pad status or state, something like that. So for now, it just updates our status. I call it test because I was testing out. I guess I could just quickly prototype this. So that's what test. So test, we're going to come in, we're going to find out, are we dealing with the left or right pad? We're going to deal with the right pad. It's going to check to see if we have a reference in case we're passing it in and for some reason the controller is off, because my controller can turn off. If you just leave it alone for like a minute or two, so that means it's not there anymore. So I have to turn it back on. So it's good to always check to see if you have an actual controller active. So the first section is going to be trackpad. We're going to update the status of the trackpad. So the reference, which is the element of game from the function gamepads, there's an array called buttons, and 0 is the trackpad. It's this little guy right here. So we're going to check to see if the state from the button that's currently is equal to, not equal to what we think it was in the previous frame. If the state changed since the last frame, it's not equal, that means we're going to save the state, and we're going to then maybe output some debug information so we can see if it's working or not. Touchpad is being touched, and touchpad is untouched. So it triggers back and forth as the state changes. So we're keeping track of state. Remember, the next thing, if it's being touched, we are going to then test the access. So 0 is X and Y. So like I said, it's a trackpad. So we can keep track of where your finger is currently on the finger. So yeah, absolute. So I'm making it like a pretty big dead zone here. So I can actually lay my thumb on the center of the pad and it won't register anything at all. Like, it won't trigger this. It won't do a log output. So this way I have to put my fingers kind of further closer to the edge to get output. So you can actually customize this yourself, like basically set up the dead zone. So you can just play around with these numbers and see where it feels comfortable, where you can lay your finger on the pad and not like trigger some kind of event. So that's what this is doing. So we're keeping track of the axes and axes. Maybe that's how, yeah, probably say axes. And that's the dead zone. So we're just arbitrarily creating a dead zone value. And it's absolute because X and Y, the origin is center, just like how a GL is. So everything is in the dead center is 0, 0, and X goes from -1 to 1. Same thing with Y, up and down. So that's why I'm doing an absolute, because it can be a negative too. It can be a negative 0.5. So that's that. And the last thing we're going to check to see if this button 0, which is the trackpad, is being pressed. You can press it in, and it's the same thing as touched. If the state is different since the last frame, update it, and then, give us some feedback about it. All right. So that's how we read the information about the trackpad. So we can know how no one's being touched. We know where it's being touched, and we know when we're pressing it as a button. Okay. So next we're going to deal with trigger. Trigger is button 0. And we're going to get the value. And I set up an arbitrary, kind of just a minimum value we need before we start reading it, because the trigger can stick a little bit and it won't go completely back to 0 sometimes. You kind of have to press hard and let go hard for value to equal 0. So playing around with my controller, I give or take, if you're pressing it in just a little bit, anything over 0.05, that means you're actually triggering it. And if I let go, no matter how many times I test it, it's always less than that. So this is pretty much a good number, I guess. You can always do like 0.1. That works too. But I decided to get a little closer to what my controller is like. But I think probably 0.1 might be a good number in general. Again, this is one of the things that might be worth being customizable. A lot of these values should be customizable, like the dead zone. Basically, I guess you consider this the dead zone for the trigger. So if it's over that, we use that value. If it's under the dead zone value, we'll automatically say 0. So this way we know that the trigger is not being pressed. So we're saving that as a value. And we're going to check to see if the current value has changed since the previous state. This is the ability to actually control the feedback on the controller. So this way it makes the vibrations go off. So if you're pressing the trigger button, you can actually make I programmed it, but I ideally wouldn't want this happening all the time. It's actually kind of annoying. But just for testing, just to see how it works, when you hold the trigger button, the more you hold it, the more intense the vibration is going to be. The only thing is I tried to find documentation about this and I can't find really anything because I wanted to know how to properly use the pulse. So I'm kind of just stuck playing with numbers and using the one example that WebVRRocks.com or .info had. So this is the best I can do without documentation. Like I said, just play around with the numbers and you can test and see how. One of them I think is intensity and the other one is like, I don't know, like how long, I don't know how long it should last. So all right, so that's just the vibrator feature, vibration, whatever, haptic feedback. So if value equals 0, we're going to just say, hey, trigger is now 0. If trigger equals 1, we're going to say trigger is at full. That means it's pressed in all the way. You got that last click in. And then else, we're just going to log the current value of the trigger. So that's it. Again, grip is easy. It's nothing. It's very simple. It's pretty much it's a lot. Every single button is pretty much a rinse and repeat. Check the state. Get the state and then compare it to the state of the previous frame. And same thing for the menu button. And I think that is it for. Then we have a matrix. That's right. Then we got the matrix function. And this one just gets the position of the controller. And it's pretty much the same thing as the head tracking. We check to see if the pad's orientation, and again we pass in which pad we want. We want 0 or 1, left or the right or left pad, and we're going to check to see if the orientation exists. We're going to check the position exists. These are kind of just defaults, and then I'm going to have a matrix that we're going to set up. So we're going to create a matrix. Excuse me. And we're going to put in a rotation, our position, and then with the proper order, we're going to multiply the sitting-standing transformation with our. Oh my God! I need to drink water. Oh man, and I'm not gonna edit this out because I don't like editing anymore. So you just have to deal with me. I'm sorry. So yeah, and we're just going to return the matrix, and that is basically the matrix that we can apply to our cube to track to be a representation of the controller. So now we're going to go into our HTML page. All right, let's scroll to the top. Man, god damn it. All right, so we're going to create a new variable for GController. It's new line. I'm marking everything new to make it easier for me to find what lines I've created for you guys. Creating some new variables. GFlyer is going to be another cube, and it's going to be our projectile. We're going to shoot one cube out of another cube. So it's going to be fun. GL Flyer is just going to be our main object, our mesh model. This is direction that we're firing it at what speed. Forward is kind of negative on the z-axis, so that's why we're going -2, even though negative speed means reverse, but it's really forward technically for us. And trigger, checking to see if the trigger is been triggered. So I'm going to test the state per frame. I'm going to, again, save the state per frame to see if the trigger, because I only want it to happen once. So once you trigger it, untrigger it, you have to then trigger again. So I don't want to hold it and a bullet keeps shooting, because I didn't program to create tons of cubes. We don't have the framework yet to do something like that. And I don't have I didn't create like a recycling object where I can create like maybe 20 cubes and then just use them and then hide them when they're off a certain range. I've done this stuff in Unity before, so it's not that bad to do it in JavaScript and a bare bones engine that we're putting together. So let's see what else we got. So that's what we're doing here with GFlyer. I think nothing here needs to change. Okay. down here, we're getting rid of this model. This is what we use to track the headset. Now we're going to create the mesh for the cube. So this way we can reuse the same mesh for two models. Going to be G model will be our controller, and flyer will be our projectile. Our controller, we're going to do an update on render. And then we're going to get the controller's matrix. If the matrix is not null, we're going to hack this into our model view matrix on our model transform. I tried to do this a different way and it just doesn't work, and I'll show you later an example of it, but we kind of have to hack this in there, and I'll explain later why we need to kind of hack it in there. I think we've done this as well in the headset tutorial. So this matrix contains the rotation and the position of our hand controller in the standing view. Yeah, I forget what it's called now. It's the standing space. There you go. The standing space. Standing space. So now that we got that, we're going to apply our scale to it because we want to make the cube smaller than it really is. And to compensate for the cube, because the cube is like the way the controller is held, I want the top to kind of match up with the cube. So the controller has to be held at a certain angle to match up, because technically the cube would be perfectly straight if I did it this way, because this is perfectly like the right angle. This is like a 90-degree angle, but the controller is not. So that's what I'm doing. I'm just adding an extra 30 degrees forward, so this way the cube matches up with this piece of the controller instead of the actual handle piece. So I'm just compensating for that. So I'm just multiplying 30 degrees by pi, which gives me 30 degrees in radians. And then I just apply that rotation to our matrix. So I'm doing a lot of raw matrix stuff. Wait till you get to this part. We're going to do that a little bit later. So I believe that's all we need for now. So you have this line, that's right, and it's pretty much the same as the previous line. I'm just rendering G model and G flyer with the exact same shader, and I didn't do any shader changes. So that's that for now. So now if we go here, and you can see our little warning that we're using the thing with this, security disabled, and we're using a Chromium version meant for WebVR testing and development only, and this thing can crash at any point. So we can get rid of those warnings. We can do a refresh, and we can see that the controller's not working, so I gotta turn it on. Shake, shake. There it is. And there we go. Our controller. And see, I press the trigger. You got the results coming down here. Hold it down. It's at full. Let it go. Perfect. I put touchpad is touching. Touchpad not touching anymore. Touching. Now I got the position. Going back to the center, the dead zone. I'm going to press in. Touching pressed. Touchpad unpressed. What else we got here? And I think it's the home button. Home button down, home button up, gripping, ungripping. That's it. Done. We're done. All that crud is done. We got it. So we got the controller tracking just perfectly, and I can rotate my workspace. It's exactly where it is. I don't really have to stand and walk around like I did in the previous thing to prove it. It's all the same thing. So gonna put it down. That's where it looks like. That's kind of where it is. So now we're gonna go back to the code. Now we're gonna have some fun. All right, let's see. So the first thing we're gonna do is show you how to get the projectile to kind of catch up or meet up with the controller. So kind of like it stays with it, kind of tracks. So the cube tracks the controller itself. To do this, it required, there's some functions I can call to do it, but it'll be just quicker, or I guess less mathematically intensive. But doing it this way, this is kind of just raw matrix stuff I'm doing. And for someone who's kind of a novice when it comes to matrix math, I'm starting to get pretty good at this. I just keep screwing up the orders all the time. That's what screws me up. So I'm getting the raw again. After I did all these rotations, I'm getting the raw matrix. So now I'm going to get the magnitude of the forward. I think this is forward, right? Yeah. Here's what the matrix looks like. It's a 16 float, array, and it's, I guess, called column. I forget it's called. There's a certain name for it. Column something and row something. I think there's a column major thing. So after you do all these transformations, you can pull out certain values out of it. The 12th, 13th, and 14th element of the matrix array is the transformation or translation. I'm sorry, the translation. So that's X, Y, Z. Very easy to pull out. So that's why I got 12, 13, 14. So I'm taking the starting position of the controller, and I'm going to add to it. And this is where this kind of important. This is the right, this is the top, and this is forward. After you do rotation and scale, all the direction values actually exist in the matrix. You don't have to do matrix multiplication with, like, let's say if I want to get like forward, I have to multiply the matrix with like an array of 0, 0, 1. So this way I can kind of get these three values. There's no point in doing a bunch of matrix multiplication when the values are right there for the plucking. For the plucking. So you can just pluck them out and save yourself from doing like 16 math equations. There really is just no point in doing all that math when the values are right there. You just got to pop them out. So that's what I'm doing. So I know the forward is this way. And forward is positive Z, but in all honesty, going forward for us is negative Z. Because of origin, Z is that way in negative. So I put a distance of -5. So I want to go a distance of 0.5 forward, basically. And so the first thing I could do, I need to normalize these values. That's the only problem with the values. The values are there, but they're not normalized. The X and Y, Z values for forward, for the top, and needs that little bit of normalization. And to normalize the value, we have to get the magnitude. So the easy way to do magnitude is the square of X, the square of Y, and square of Z added up together, and then you do a square root, which gives us the magnitude. Yay, trigonometry. I think this is trig. Okay. So once you have the magnitude, then all you have to do is divide each component by the magnitude, which then gives you a normalized value. Normalized value is a value between, is it 0 and 1 or -1 and 1? I forget now. I think it's 0 and 1. I think normalized is between 0 and 1. So it creates a number between 0 and 1. So this is X, Y, Z. So I am taking the starting position of our controller, then adding 0.5 in the forward direction. So if and of course it turns itself off. So if I'm pointing this is the forward direction. If I'm pointing this way, that's the forward direction. So I need to know the position basically of this spot and then add the forward direction by, so since it's a normalized value, it's only going to go as far as 1. But if I want to go a little higher than that, that's why I have 0.5. Kind of pushes it out a little bit and right in front. So that's what's going on. I'm just, like I said, I'm just doing raw matrix math-ish things to get the position. And then I set the position for the flyer. So if I do that, switch back over, refresh, and as you can see, now the cube stays 0.5 meters, I guess half a meter away from the controller. No matter where I point it to, it'll always stay half a meter in front of the controller, which is kind of neat. The only thing you notice is the little cube is not rotating because I'm not applying rotation. I'm not doing any of that. There's a lot of issues with doing that, but we will fix that later with something else. But yeah, so there you go. Now I showed you how to kind of basically lock a second item to the first item by using forward direction and a little bit of math. So we're gonna go back here. So yeah, crazy, hacky, fun stuff. Now we're gonna do, this is gonna be the fun part. We're gonna do the exact same thing, but now we're gonna apply it to some stuff. So if we're pulling the trigger, I'm gonna set it to true. And if you're not pulling the trigger, we're gonna set it to false. So we can only shoot it once per every time you press the trigger button. So we're doing the exact same thing. We're just, but this time I'm putting a distance of 0.1. This is going to be the starting position of our projectile. So the projectile is going to appear right in front of the controller, closer to the controller than the previous lesson. Because the previous example was 0.5. This is 0.1. So it's going to be like right next to the controller when I shoot it. So same thing. And I'm basically repeating this part. This should be, I should only do this once because there's no really reason for this. This is kind of a duplication. But I don't know, because I just don't feel like it. I'm prototyping. I'm not making things perfectly efficient at the moment. So what I want to do is take the normalized direction that I'm starting with and saving it in flyer direction array. So this way I know when you press the button, what direction was I looking at? And XYZ is the starting position. So I'm going to start here, and this is the direction I'm going to be moving at every frame. So once you know the direction, we're going to then apply, we're going to add the direction times our speed times delta time. So I think I have it going like half a meter a second, or I forget what it was. What is it? Scroll to the top. -2. So we're going 2 meters a second. So that's what we set it up for. So it's 2 meters a second, and we're going to go, and just like I said, we're just going to move in that direction 2 meters a second. So if I do save, go back, refresh, the cube went bye-bye because it was going in a certain direction. But now if I point it at us, because there you go. There you go. Now it just shoots. It just goes in whatever direction I aim it at. It seems, oh, that makes it so easier. Now this the screen, the room is orientated to how I see things. So yeah, turn it back at me and pow, pow. And there you go. Voila. Now we have a shooting gun. We made a gun. That's fracking awesome. I don't know about you, but this is great. Like this is kind of cool when I did this in Unity a couple of months ago. This is like 10 times cooler building this from scratch. It really is. I don't know about you, but I think it's fucking amazing. Yeah, see, my controller went back to sleep. So I went looking online, and I was trying to find a 3D model of this, because it'd be awesome if I could just have a model, because I don't want to use a cube all the time. And I found this in the Google search, and I'm like, why did it take me to this page? And I'm like, that's why. Mozilla A-Frame is kindly enough to link to the object file model of the controller. That's great, because we can load object files. Remember, I wrote a lesson for that. Don't have a lesson for MTL, but we have a lesson for OBJ. So that's great. So you can download it, but there's only one problem. That OBJ comes with several pieces of the controller. So we have the body, we have the trigger, we have the trackpad, and I think the home button. Those are and the grip. So you have all these pieces in that one file, but we didn't code the object file to load multiple meshes. We can only do one mesh inside an object file. So I actually had to modify the object file and pull out all the other data except for the body. So I left the body alone in the file, and I created a new file, like right here, the VR controller Vive _ body, and so yeah, it has like object body, and then this is just all the information to build that thing. And I kind of just, once I found this, what the hell, this is a real long file. So after this, it said object something else. Like, oh, okay, so that's the start of another object. I just wiped it out, everything off after that. So that's going to be the file. So if you could go to GitHub, you can get that file, so you can finish the rest of this lesson. So instead of dumping this all into a script tag, this is actually 1.5 megabytes long. It's huge. I wanted to load it in. So when I was loading it in, there was a problem. There was actually a bug. So I should go here first and fix the bug. So one of the things we're going to do is create a new variable in the parse object text and call it char. It's just a temp variable. And then when we go here, should be around line 50 inside the function. Let me see. This was what originally was here. This wasn't working perfectly for the controller. Worked for our other model, but not for this one. I was getting not a number error for every X value. So I managed to figure out that if I just do this, I forget why, but this is just string parsing. So I'm just parsing everything a little bit better, and that fixes it. So this line becomes these two lines, and I think this stays the same. I'm kind of like, basically what I'm doing is taking the line and I'm skipping 3 characters. So basically, apparently there's more characters. So I'm just kind of trying to crop out everything that's there. And then I'm splitting it into an array. So that's all it is. I'm just, because I think I was doing shift and the shifting wasn't doing anything. So I don't know why. It was doing something before, or I was mistaken, but that's not working anymore. It created an extra element in the array. So instead of like 3 elements, it was creating 4 elements, and the first element was null. So it's kind of screwing up the model. This way seems to work better. So that's one bug fix in our object loader, and that's inside the parse object text. Now we're going to be able to try to load things in. Scroll to the top. And I said in a previous lesson, I'm going to fix this up to use promises, so we can load up VR and resources together, like in parallel. And when they're both done, then we can kind of continue processing things. So one of the first things we're going to do is add this parameter, use promise. So it's going to be backwards compatible. We can still be able to use this with the complete handler, or we can call start with saying, yeah, use the promise functionality. So it's still backwards compatible to what we have. So if we use the promise, we kind of create a promise. We save the resolve and reject callbacks, so we can handle them, because we can't handle them right now. We can only handle them later when we're all done. So that's why we got to save them for future reference. And this is a static class anyway, so it should only exist one class for resource management. And then when we're done setting everything up, we just call next item. This is the same thing we were doing before. So that calls load next item. So we're gonna have to create a new loader for object files. So it's very simple. It's just like it's the same thing as our other ones. It's a rinse and repeat. The only big difference is what type it is. So I'm just saving it as an object. So that goes away. That goes away. We have next item, and the only thing we do is here. If the queue is empty, then and if the resolve exists, we just call the resolve, and then we end the end. So we'll resolve our promise and kind of alert saying, okay, we're all done processing this. The next big thing is in the switch inside that load next. If the next thing in the queue is the object file, we're going to use Ajax to load up the file. And this is why we kind of need to set up Chrome with that little cross-domain thing, because even though it's not really cross-domain, it considers anything loading up from your hard drive directly as cross-domain. So it doesn't, we have the same problem with textures. We also have so we're gonna have the same problems this way. So in the reference, I'm gonna save an object file. Anything you see me put an F in there means it's kind of like custom. I don't know why I picked F. I originally picked F for function, but I've just been keeping it like that for even object names that don't originally belong to an object. So I'm saving the name of the resource that we're trying to load to, and then it's really simple Ajax stuff. You open, you get the source on ready state. I have to create a new event handler to handle Ajax, and then we do a send. That's that for now. I don't think there's anything else happens here. And then in our on download thing, we have to check the state, because it goes through a couple of different states, like starting, loading. So when we are in the done state, we take the resource text, which is all the text data from that object file, and and we parse it. We send it that function we just fixed. So we're going to parse it, and it gives us, I forget what it gives us. It gives us a bunch of data, it gives us the arrays for index and vertices and UV coordinates, blah blah blah. We pass all that to our create mesh VAO. So it creates our mesh object with our buffers set up for each type of vertex data. We save that, which we don't really need to save here because we're going to get that later using the object name. And then we just call the next item. And once it's done, it just loops. It goes and downloads one file at a time. And the only thing we need to do is on our resources, we got to add these raw objects or these properties to store references to our resolve and reject callbacks. So then we have another HTML page I have set up. We're going to bring in the object loader. It's pretty much the same as the previous one. Now the only difference is this to do is now officially done. So create a new variable called my resource promise, set up without the callback because I don't need the callback anymore. Load object, I'm going to live controller, that's the name. I'm going to reference this back later when it's all ready to start loading. This is the object file that exists locally, and then start with the promise. This is our VR promise. It has our controller, it has our loop, it has everything set up. And then we have promise all. when VR promise and the resource promises are complete, you can kind of consider them threads. When the two threads are done, then we're ready to start. So that's kind of what I want to do when I created the VR thing to get. So this way we can kind of load a bunch of things in parallel, and when they're all done, we'll start actually doing the main loading of things. So let's see, what are we doing here? So we're going to modify the flyer. The flyer is going to be different. It's not going to be a projectile. It's going to be something else. It's going to be a new weapon. We're building a new weapon this time around. So we're going to create a model, and we're going to grab the Vive controller from our mesh cache. Because remember, because that's the loader saves everything into our mesh cache. We're going to set a position. We're going to set a scale. That's fine. The flyer has its own little scale, new scale for it. This is a function. I tested 3 different types of functions, and this is like the best results I got, but it ends up being futile. I'll explain that later to Eler. Okay, so let's see what else. So pretty much the same thing as our model. You know, we're getting the position of the controller, just like in a previous example I was doing earlier. And now we're going to track that second cube. So I'm basically doing a second copy. I should do a better job of this. This is the Quatorian all the way. This is the shitty buggy way I'm doing up here. I'll show later how buggy it is. Yeah, we're starting to dislike degrees. So let's just get to it. So we're going to get the matrix transformation from the controller. Let's see, and again we're getting the magnitude, like the forward magnitude again, and we're doing the same thing instead of but we're just going to apply. We're going to take the X and Y translation of our matrix, and we're just instead of saving the X, Y, Z, we're just going to just append. So it's kind of like the same thing. This one, instead of where I'm adding this up, you know, it's practically the same thing. So I'm just moving flyer to a certain 0.7 meters in front of the controller. So once I got the translation, I add the scale, and then I put the raw in. So if I save that, we go to our Vive model, we refresh, we turn on my controller, and ta-da. And we turn the flyer into a sword. So we have a sword. See, now I need sounds. I need to learn how to do effects. So maybe I can turn the sword into like a lightsaber. That'd be great. Go whoa, whoa, whoa. You know, I need sound effects, and I need special effects. And there's a lot of things we need to do before we get to have some real fun. But there you go. There we go. That's it. It's not that bad. And we got the controller. This will look better if I had a texture or we use lighting, so this way you can see the contours of the controller. And it's missing the pieces like the trigger. Like I said, I took them out of the object file because I can't load multiple parts in one load. So yeah, there you go. This is fun. This is great. You know, we got now. If I had both controllers going, I can have a sword in one hand and a gun in the other. I think once we have the framework more put together, I'll probably come back to this. And you know, once we have a collision detection working, maybe I'll have like cubes being thrown at us, and we can kind of smack the cubes out of the way using our sword. I guess we can do maybe like you know, Fruit Ninjas type of thing. And then we have the other controller which has projectiles, so we can just shoot cubes at cubes, or we can kind of just like destroy cubes with a sword that comes within range. So that might be fun. So let me see. I'm getting tired. All right, so I'm going to show you the shitty way of doing this. Shitty. All right. I'll show you how bad it is. It kind of works and it doesn't kind of work. Oh, oops! Did I screw up somewhere in the code? At least. Oh, okay, that's right. Because now I'm trying to use the position, the transform. There we go. As you can see, it's kind of funky. It kind of works and kind of doesn't work. It's I know I'm probably doing something wrong myself. Like it kind of works. It's wacky. Try to show you why it's crappy. I need more water. I'm gonna try not to drink water. So we're basically doing the same thing, trying to set position, like how we did. And I'm trying to get the rotation from our matrix. And then I'm trying to use Euler to pull out the Euler values from our quintillion. In rads, though, I had marked this in rads because I got to remember that this comes out as rad values, not degrees. And the thing is, our rotation that we built into our transform uses degrees. So, sorry. So, yeah, there's a lot of conversion going on. I'm going from quintillions to Euler in rads, and then trying to turn the rads into degrees, which then turns it back into rads, and then tries to add the rotations to try to create a rotation transformation matrix out of it. There's too much crap. Like it's literally too much back and forth, going from one type of data to a different type of data. It just doesn't work. And especially with the data comes out as quintillions, it's just better off sticking with that. And like I've said in previous lessons, that at some point I have to switch over because of gimbal lock and other problems. It's so much easier just to use quintillions than it is to use degrees. Degrees seems to, even though degrees made it easier for us to understand and get started in the very beginning, the more complicated things get, the more in a way they are. Since everything else uses quintillions, we kind of should use that, especially that hardware. And there's like I said, it's gimbal lock. You can lerp between them. Those are some of the benefits. There's other benefits. I think I keep reading about it to try to understand more of it. So yeah, I tried 3 different quintillion to Euler conversions. The first 2 were horrible. Like, using all this, it was all over the place. And then I got the 3rd one, and it does a better job of it, but it's not perfect. I might be doing something wrong. That this is where I found the bug in the rotation. The position had to be Y, X, then Z. So once I fixed that bug, everything started. Well, not this because I'm doing raw. This started working pretty good. So yeah, in the future we're gonna have to get rid of degrees. And see if I can research more on how to. I want to still use quintillions. I know the quintillion objects out there that I saw that you can kind of just tell it to rotate by 45 degrees, or you can tell it do it by rads actually. But it's still, it's just one's rads and the other one's in degrees. They're practically the same thing. I just have to do is this one little math equation to turn like this one turns rads to degrees. And if you flip pi and 180, like flip them around, then you can do degrees to radians. So, yeah. So that's it. So I hope I don't know how long this one was long. Actually, let me. Oh no, go there. So let's get rid of the shitty one and do it the right way. Because this is the way it really should be done. So yeah, refresh. And of course my controller shuts down. And that's what it looks like. This is the default values when the controller is off. And I probably screwed up somewhere. Oh, that's right. Ah, my God. You guys can leave now if you really want. You guys can leave now. I don't know. I don't know what else to say. Refresh. So, oh yeah. So, yeah, you can leave. I'm just gonna babble on a little bit. So yeah, this is probably the end of the WebVR stuff I'm doing for now. I'm gonna start moving on to other areas. I'm not exactly sure where I want to go to next. I know I was thinking about doing Xbox controller. Tell me if you guys want to do Xbox controller. It's pretty much the same thing as these the Vive controllers. You connect to it and then you save the state, and then you check the state every frame. It's pretty much the exact same thing. So I don't know if it's even worth doing the Xbox controller tutorial. Like I said, it's practically the same thing as this. I also was thinking about doing maybe text rendering. I would love to do some text rendering with glyphs, textures. That might be useful. That's going to be useful down the line. So might as well do that sooner than later. Trying to think what else. There's like a lot of stuff to do. I want to do voxels. Voxels are fun. It's like like Minecraft stuff. So, I think one thing that maybe I should do is picking. So this way I can use a mouse to actually click on an object, like a 3D object, and move it. So right now I can only move the camera, the scene, but actually saying, okay, I select that and I just move the object itself. So maybe I should do that first before I do anything else. So this way we can start interacting with our 3D environment. So this way we can do like UI as well. So if we want to have like little bits of UI that exists in VR or in our 3D canvas, we can do that. So we can select objects. We can create like a UI layer that has like a different projection, ortho something. I forget, ortho projection or whatever. I forget what it's called. So this way it doesn't rotate. It kind of stays flat. It has like no depth. Z is just like a layer effect instead of a depth value. So yeah, maybe I should do picking. Don't bother with Xbox controller because I don't think you guys don't need that. Maybe down the line when we do like more gamey stuff, the Xbox controller can be useful. So maybe you do picking first. Maybe text glyphs, or maybe I'll go to voxels. I like to play with terrains more. I really want to revamp the engine. I need to. There's actually one thing I want to learn to do is I think it's called FBOs. You know how we kind of have our VBOs, VAOs, the vector array objects, which allows us to put our VBOs in. So this way we only have to load up one VBO, one VAO. We only have to load up one VAO for the shader. So this way, instead of loading all those buffers, we only load one buffer basically instead of 5 or 6 or 2. So it lets you kind of just pre-create all the buffers and then save them for use later. You can do the exact same thing with uniforms. You can do chunks. I think they're called FBOs, or unless that's something else. I don't know if that's. So there's something for uniforms as well that's available to WebGL 2.0. I think that's new. So this way you can kind of predefine a certain thing, and no matter what shader we're doing, we're always going to need to use the exact same projection matrix and the same camera matrix. So instead of, if you're gonna have like 10 shaders running, there's no point in loading those values for each shader. So it'd be kind of great if we can load it in once, like at the top of the render loop, and then every shader can kind of just take that FBO. Like I said, I don't remember which acronym it is, because I think FBOs might be the frame buffer object. That might be something completely different. That we could. I would definitely want to tackle that too. Frame buffer object is probably something we're going to need to do for picking. Creates a different frame. It's kind of like a texture that you can kind of render into and then use the information that comes from it. So yeah, there's like I said, there's so much I want to do. So, and I'm just curious what you guys want to do. So tell me what you guys want to do, are interested in, what topics, maybe something I could do next first if it's not too heavily complicated. I know I would like to do particle system. That might be fun. A particle system. Yeah. It still feels like an early part of the engine. It's like there's still so much to be done. I really want to revamp the engine, but I need a couple small pieces like the uniforms. Having predefined uniforms that we can load them in kind of globally. That's something I need to tackle first before I tackle redoing parts of the engine to kind of uniform it. I want to create a namespace and actually give the engine a name. I don't know what to call it yet. I don't know if you guys have any cool ideas. Some ideas I've been writing down is called FunGL. Name it after the series. Fun with WebGL. Just call it FunGL. And then when I say FunGL, I start to like make fun of it, calling like fungal, like a fungus. So I just think maybe we can call it fungal, or just call it fungus. If it's called either fungal or fungus, I can use like a mushroom as a logo. So that's like quick and easy logo design right there. Just a mushroom. Or just call it FunGL. I don't know, with the smiley face. I don't know. If you guys have a cool name that we can give the engine, I'll probably start at some point creating a namespace and start building objects in that namespace. So yeah, I like how this series was originally going to be just to build a little model viewer, and now we're actually trying to do VR. We got a shooting gun, we got a sword. We're looking to try to actually build a game engine out of this. It's kind of awesome. I don't know how long this video is now. I'm really sorry. I ramble too much at these little things. So yeah, if you guys have any ideas, tell me. I'm just curious what you guys want to do. Yeah, that's it. Like, I know I keep saying that's it, and it's never that's it. Like Steve Jobs, there's one more thing. All right. So subscribe. Tell me in the comments what you guys would like to tackle next in WebGL, and I'll see you guys in the next lesson.